Next up, we have a quick review on 4.4 linear inequalities in two variables. So an inequality has a less than or a greater than sign. So we might be asked, what is the solution of the inequality? Y is less than or equal to x minus 1. Since it's less than, it's not just a line, it's a lot of points. So we have to graph to show the solution. So another thing we might be asked to do is just graph y is less than or equal to x minus 1. So now the y-intercept is -1, so we're going to plot that on the graph. The slope is 1, so from there we're going to go up 1 over 1 and plot that point, and then draw the line through the points. Now, because this is equal to, we're drawing a solid line. Everything on there makes that inequality true. Now, we want to know where to shade. So do we shade above or below? The easiest point to check is 0, 0. If I plug in a 0 for y and a 0 for x, I get 0 is less than 0 minus 1. So 0 is less than -1. And that's not true. So 0, 0 can't be in our solution region. So the solution is all of the points below that line. So that's where we shade. So when we're in the slope-intercept form, less than is going to shade below the line, greater than would shade above the line. So here's an equation with a greater than. Y is greater than 1/2 x plus 3. The y-intercept is 3, so we're going to plot that. The slope is 1/2, so we're going to go up 1 and over 2 and plot that. Now this time there's no equals to. Since there's no equals to, then that's a dotted line. It says anything on that line is not part of the solution. And now greater than is above the line, so that's where we shade. And of course we can check the point 0, 0. If I plug in a 0 for y and a 0 for x, I get 0 is greater than 3, and that's not true, so 0, 0 is not in my shaded region. So we have a way to quickly check our answers. Now, when we're given an equation that's not in the slope-intercept form, now we have to be careful and think where we shade. So first of all, we're going to plot the intercepts. The x-intercept is when y is 0. So 4 times what equals 24? Well, 4 times 6 is 24, so we're going to plot a point at 6. The y-intercept is when x is 0. So -8 times what equals 24? -8 times -3 is 24. So we plot that point. This is a solid line. So we're going to draw because that's equals to, we're going to draw the solid line. Now, if I were to plug in a 0 for x and a 0 for y, I would get 0 is greater than 24, and that's not true. 0 is not greater than 24, so 0, 0 can't be part of my solution. So this says greater than, but greater than is not part of the solution. So this is where we have to be careful. If the y term is negative, when I solve for y, I'd be dividing by a negative, and a negative flips the sign. So this becomes less than. So less than, we shade below the line. So when we're in standard form, if the y term is positive, then greater than is above, less than is below. If the y term is negative, that flips the sign, and that's what we have to shade. Lastly, if we're given a graph, we want to be able to make an equation from the graph. So on this graph, we can see the y-intercept is -3, so we know we're going to have a -3 at the end of our equation. The slope is, we can see we go up 1 and over 1, so the slope is 1. So we have, for the line, y equals 1x minus 3. But now we have to figure out, do I put less than or greater than, and do I have equals to in there? This is a solid line, so I have to have the equals to. And we're shading above the line, so that's greater than. So then our equation is y is greater than or equal to x minus 3. And that's our quick review on solving linear inequalities in two variables.